Hello, ladies and gentlemen. Advanced Algebra Study Guide, Chapter 7.6, Exponential and Logarithmic Equation. All right, so we're going to be solving these equations, and we're going to be using some of the properties and some of the things that we have learned in this chapter. This takes practice. Rewatch it if you need to. Try the problems on your own. Rewrite it. See if you can remember the steps to solve it. So remember what our goal is. Our goal is to get x by itself. So the first thing we got to do here, however, in this problem is get rid of the 8 on the left side. So to get rid of that, we are going to need to divide. Now we have okay, 2 over 8. Let's simplify that to 1/4. If you really wanted to, you could change that to a decimal, but we're going to use 1/4. Now, we're going to use one of the things we learned for solving these types of equations. We need to get rid of log base 81. And remember, what you do to one side, you do to the other. All right, here we go. So I'm going to rewrite this as okay, see what I did? I made a big 81, a base, and I made the other parts the exponents. Because what's going to happen there, remember, is these are inverses of each other and they cancel out. So we're left with x minus 4 on the left. And then if we simplify 81 to the 1/4 power, all right, let's see if that'll give us a nice number. 81 to the 1/4 power. Well, look at that. It gives us a 3. So we end up with x minus 4 equals 3. One step left, add 4. We find out that x equals 7. Okay, rewatch that again if you need to. Look at what I did in each step. All right, number 49. Now, you will notice that the base is a 10. Okay, the base is a 10. So what I can do, again, what I do to one side, I do to the other. Since the base is a 10, I can do this. Okay, that's the base of 10, remember. And so what happens when I do that is the log 10, again, that disappears because it cancels, and I'm left with the 5x equals the log of 120. Well, we can take the log of 120, okay, because that's a base of 10. So log of 120 is about 2.079. So 5x is approximately 2.079. And now I can divide by 5. So x is approximately 0.42. Again, it takes a lot of practice. This is very new to all of you. All right, number 50. So in this one, again, we want to get x by itself. So the first thing, though, on this one is I need to get rid of the 4. this 4. So I'm going to divide by 4. So what am I left with? I am left with an e to the 7x power equals 32 divided by 4, I believe, is 8. Now, how in the world do I get rid of the e? Okay, well, remember, that's the natural log. So, again, what we do to one side, we do to the other. We can rewrite this as ln e to the 7x equals ln 8. These cancel out. Whoops, that's an x, not a 5. This is an x. Okay, this cancels out. So we're left with 7x equals ln 8. Okay, so what I could do here, instead of figuring out the ln 8 as a decimal, I'm just going to go ahead and divide by 7. And so I can just type it in the calculator like this. So I can go ahead and do ln 8, make sure you close it, divide by 7. So it's about well, if we round it, so 0.297, we could say 0.30. Again, rewatch, see what we did there. We had to get rid of the e, and to get rid of the e, we had to use the ln, natural log. Okay, the next one, I see that these numbers are off a little bit here. Okay, this was actually problem 52. This was problem 53. This was problem 51. I thought that was already taken care of. All right, so problem 53. So the first thing we're going to do on this one is we are going to get rid of the plus 6. We're going to take away 6. So we have 9 to the 3x power equals 28. Now, I got to get rid of the 9. So, let's see. To get rid of the 9, and I've got a base of 9, I need to use log on both sides. So here we go. So I'm going to rewrite this now as log base 9, 9 to the 3x power equals log base 9, 28. Again, what I do to one side, I do to the other. And again, I picked 9 because this base is 9. So what happens? Well, again, this cancels. So we're left with 3x equals log base 9, 28. Well, we can use our change of base formula on this. So that would be 3x equals log 28 divided by log 9. All right, so let's see what we get. First, I'm going to move this down a little bit more. Okay, so here we go. Log 28 divided by log 9. So we're going to say about 1.517. Then we're going to divide that by 3. Type that into the calculator, and we should get approximately, let's see. So now we're going to divide that by 3, and we should get approximately 0.51. Re-watch them and think through them very carefully. Okay, moving on to the next page. So again, we're going to solve and we're going to round to 2 decimal places. Wow, okay, so the first thing that I notice here, ladies and gentlemen, is that I've got a log base 8 on both sides. So the first thing I want to do is I want to have them on the same side. So I'm going to rewrite this as log base 8 x plus 6. Now if I move this to the other side, it's going to become minus log base 8 x minus 2 equals 2. Okay, I moved it from the right to the left and it becomes minus. Now using my properties, that minus sign means it's a quotient. So I've got log base 8 x plus 6 divided by x minus 2 equals 2. Well, to get rid of the log base 8, what I'm going to do, I'm going to make these two things exponents, remember. So I'm going to put a big 8, and I'm going to do, so 8 squared. I don't have a lot of space here, so I'm kind of squeezing it in there. So now the 8 and the log base 8, again, they cancel each other. And so what I have now is I have x plus 6 over x minus 2 equals 8 squared. Now, 8 squared becomes 64. Okay, so I'm going to rewrite that as 64. Now, I'm going to multiply both sides by x minus 2. So let me switch colors here. So what I'm going to do is I'm going to multiply this side by x minus 2 because I'm undoing the division. And I'm going to multiply this by x minus 2. So over here, that cancels. All right, well, now we have x plus 6 equals 64 times x minus 2. Okay, well, from here, it should be routine. Solve for x. Distribute. Okay, I'm going to go through and solve it, and I'm not going to talk as I solve it, because this is now intermediate algebra, solving for x. Here we go. Okay, it does not turn out to be an integer. It turns out to be a fraction, which would give you a decimal. So we're just going to leave it as positive 134 over 63. All right, rewatch that. Think about each step very carefully. All right, the next one. So we notice we've got log base 2, and then we have another log base 6 inside x. Okay. So first thing we're going to do is we're going to get rid of the log base 2. So again, I'm limited with space here. So to get rid of log base 2, I'm going to do this. This cancels. So now I have this. Okay? So 2 squared, I'm going to change that to a 4. Now I'm going to get rid of the log base 6. So again, I'm going to do this. So I end up with x equaling 2 to the 4th power. Well, Whoops, not 2. Let me back that up. Sorry, ladies and gentlemen. I made a big boo-boo. That's a base of 6. My apologies. My goodness. Let me rewrite that. So we've got log base 6x equals 4. Okay. So base 6, not base 2. Base 6. So we are going to go 6. There we go. That's better. That cancels. So x equals 6 to the 4th power. Okay, 6 to the 4th power becomes 1,296. Okay, number 54. First thing we got to do is get rid of the 15. And we're just going to leave that as a fraction. That's 1/3. Okay, previously, just like we did with others, we got to get rid of the base 125. So I'm going to do this. Now, 125 to the 1/3 power. Is 5. That's x minus 2. Okay, x minus 2 equals 5. So add 2. All right, moving on. All right, number 57. First thing we're going to do is we're going to add 5 to both sides. Next thing we're going to do is divide by 2. Now to get rid of the e, we've done one like this before. We're going to do ln to the both sides. Again, I'm limited with space. Sorry about that. This cancels. Now divide by 4. So you can type that into your calculator. And you're going to get approximately 0.62. Okay, the next one, number 58. So step 1, we're going to get rid of the minus 2. Okay, now we're going to get rid of the base of 6. So again, limited with space, we're going to do this. That cancels. We are left with using the change of base formula. Okay, so now I'm going to go ahead and approximate that. So I'm going to take log base 52, or log 52, sorry. divided by log of, let's see, that's log of 6. So we get approximately 2.21. And then we're going to divide that by 4. So about 0.55. Okay, number 59. There's another 10, so we can just use the log. We can write log 10 to the negative 3x equals log of 570. So, negative 3x equals log of 570. Divide by negative 3. So x equals log of 570 divided by negative 3, which is approximately negative 0.92. All right. We're getting there, folks. We're getting there. The next one, I see log base 4x plus log base 4x minus 2. That's telling me the product property. So I'm going to rewrite this as log base 4x times x minus 6 equals 2. All right, now I need to get rid of the log base 4, so I'm going to do this. All right, so that leaves me with, and 4 squared, that would be 16. Okay, I'm going to distribute. Oh, it's a quadratic. All right, to solve the quadratic, we got to set it equal to 0. So subtract 16 from both sides. So that would be x squared minus 6x minus 16 equals 0. Okay, now you can factor that. This one is factorable. So x minus 8 and x plus 2. All right, so we get 2 solutions. However, one of those solutions is extraneous. If you would check them, we would find out that the negative is extraneous. All right, last one for this section. One is just like number 55 up above. We've got log base 3, log base 5, so we're going to start off by getting rid of the log base 3, so we're going to do this. Three to the first power is 3. Now we're going to get rid of the 5, so we're going to do this. So x equals 5 to the third power, and 5 to the third power is 125. Okay, study each of those carefully, redo them, think through them. Okay, this is not the easiest. You have not done a lot of this, so you have to practice, practice, practice. All right, good luck, ladies and gentlemen.